Ready, kids? Ready, studio audience? In 5, 4, 3. Welcome to another day of pre-calculus. Who's ready? This is studio audience. Hey, yeah. All right. Welcome to the game show. Okay. Now, today's word is. Or around that. If anybody has ever studied Greek or Russian, Russian has the same alphabet as Greek, actually. Anybody? All right?
Yeah, we all know.
Absolutely, sure. Okay. Well, anyway, in Russian or in Greek, this word is pronounced synopsis.
Of course.
I guess that.
All the letters are different in Russian and Greek. It's all very different. All right? But that is, the first thing you have to do in Russian is like spend 2 weeks learning the alphabet. Then you actually go on with the language. It's pretty cool. So, synopsis. 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 Sounds a lot like an English word.
Synopsis.
Synopsis. Oh, you kids are clever. Synopsis. So that is Greek for synopsis. And if you were to, let's say, write a synopsis on a movie or book, you would be writing a what? Summary. Good. So a synopsis is a summary. How do we use that in mathematics? A summary.
Sum of the garage.
How about sum? Right? Sum is a fancy word for what?
Summation.
For summation, or that means add up a whole bunch of stuff, right? Addition, exactly. So this is going to be some kind of addition today. That's what this is. Interesting.
Yes.
Right?
I like addition.
Well.
It's not normal.
Let's try it, shall we? Okay, find the sum of the following sequence. Right? Sum. That's addition, right? Yeah. Okay. There's something very different, though, very different about this sequence compared to the sequences we did last time in the homework. 3, 5, 7, 9, 11.
It ends.
This is dead end.
Finite.
Can you have a sequence that ends? You can. Instead of an infinite sequence, it is a finite sequence. Exactly. Very good. All right. So we have a finite sequence. So some sequences are just dead end. Right? Okay. So it says find the sum. So that means what? Just put plus signs instead of commas? Pretty easy. Okay. Now this is called something slightly different. If you have a sequence, it's a pattern separated by commas. But if you have a pattern separated by addition signs, it is a series. Exactly. Right? So this is a series. Not a big difference. It's still a pattern, but you're getting a sum now. Right? So let's add this up. Ooh, I like this. 3 plus 7 is 10. That's nice.
Yeah, another one.
And 9 plus 11 is 20. Put the puzzle pieces together. 10, 20 plus 5? 35. Makes it easier to add in your head. Okay, so that's 35. All right, hot dog. Okay, now let's do example B. Oh my gosh, what is this gigantic?
Summation.
Oh, you kids are just so smart, aren't you?
Sigma.
Okay. Take all your honors. Okay, this is the Greek letter sigma.
No, hey, you were right.
That is a sigma.
I got that right.
That's the Greek S. Very good. Okay, what in the world does it mean if you have a gigantic sigma thing on the page? Well, you know what? It originally came from synopsis, which means use a sum, because of course a lot of these mathematicians were Greek, right? So they said, let this be the universal symbol from now on to find a sum. So what we have to do is this. What we have to do is take 1 and plug it in. 2 times 1 plus 3 is what? 5. Now it's a summation, so we'll do plus. Now, what's the next number after 1?
2.
Well, actually, how many numbers are between 1 and 5?
Infinite.
Infinite, right? 1.7, 2.6, e, pi, square root of 22, 1.648, infinite numbers. But in a summation, you are assuming that we're going by integers. So you do not have to plug in every number in the world between 1 and 5 because we never get done, right? So you could actually do 1, 2, 3, 4, stop at 5, right? So 2 times 2 plus 3, what's that?
7.
7. Okay. 3 times 2 plus 3. 9. Let's make it a pattern.
11. 13.
11, and then finally, so it just made a pattern. It's a concise way to write a pattern, all nice and consolidated. Very nice. I like that. Matter of fact, here's why it made a pattern. Do you know what this is called right here? That is the what? 2 and plus 3. We just write down the homework.
That's the implicit.
That is the explicit formula. that cranks out the whole sequence.
Good job. Steve.
Was that Steve Bracelet?
Yeah.
That was good. That was very good, Steve.
Steve got a plus
Right on
10.
the, yes, that's right. All right, let's see, where are we here? We're down in this class. Board's getting so full?
You could stretch it
You
out.
can make
Yeah, you
the
could stretch it
space
out.
out.
Have half of it.
Yeah. I could actually put those on the computer. That's a plus 10 board over there. Maybe we'll show it someday. All right?
Maybe not.
Okay. All right. Now, what we have to do is add all this together. So it creates a pattern, explicit formula, and it tells you what to plug in and then where to stop. So let's see. Ooh, puzzle pieces. I like 9 plus 11 is 20.
7 and 13.
7 and 13 is 20, so that's 40. Plus 5, 45.
I like 35 plus 13.
Okay, or yeah, sure. Lots of ways to put the puzzle together, right? Okay. You don't actually have to do 5 plus 7 is what's that, plus 9 is what's that, plus 11. You don't have to do that. Okay. Find the pieces. All right. So that's how you do it. Now, this is known, by the way, since we had a dead end. This is known as a what type of series? This is a finite series, just like a sequence. However, the next one is a what? Infinite series. All right.
However, shown too.
Gee. Well, I'm going to plug in 1 and get 5. Then I'll get 7. Then I'll get 9. You know what? If you keep going, what's going to happen? If you add up all those numbers, and eventually you're in the billions and the trillions and the quadrillions, if you add up all those numbers, don't you just get infinity? Yeah, exactly. You don't get an exact answer. You know why you don't get an exact answer?
Because you can't ever reach infinity.
It's, is y equals 2x plus 3, is that just a line? It's linear? If you just keep on going and keep on going, what is that called again? If there's no boundary?
Divergent.
That is divergent. This series is divergent. It's a divergent series. Because when you keep adding numbers, you just get bigger and bigger. You never get a definite answer. Okay? So you can call this, you have divergent sequences, now we have divergent series. All right. Nice. Okay? Now, there is one type of series where you can actually get a numeric answer even when you add infinite terms. And that is a, guess what type of series? If you have a convergent series, you actually could get a definite answer. Even if you add up all the numbers and keep going, you'll actually get an answer. So, here's what we'll do. In C, matter of fact, I bet C might be one of those. All right, so let's try this. In C,